So good morning and welcome everyone to the class on smart materials and structures. So before starting, can anyone let me know what we were dealing in the last class quickly? Which was the topic we were dealing about?
Basic attenuation mechanism,
Okay.
fiber optics attenuation, fiber
Yes.
performance,
Yes.
and characteristics.
Yes. Which type of characteristics was it?
Transmission,
Yeah, transmission characteristics, and also you just
attenuation and
forget.
dispersion.
Yeah. And we also dealt with different types of sensors. Do you remember about Fabry-Perot cavity sensors, what we dealt about? So I told you the types of sensors in which
Yes,
we are
ma'am.
focusing on Fabry-Perot sensors. So I dealt about exactly what all will be associated with Fabry-Perot sensors. So
Yes,
we
ma'am.
dealt about the principle, how does it operate. So mainly we have two mirrors, mirror 1 and mirror 2. So here will be associated with an coating of diaphragm, whereas in mirror 1 you'll be having an coating of an dielectric material. So partial amount of light rays which passes through mirror 1 will be reflected, because the mirror 1 what we use will be partially reflective type of, and fully reflective type of mirror will be across mirror 2. So the remaining part of the rays of light will come and reflect back. So regarding this, we just explained the principle, how the variation in the pulse of the light input comes into picture and how the process goes on. So we dealt about the principal process of Fabry-Perot sensor, and I also told that how the incident and the reflected ray will vary. And we also dealt about the different type of Fabry-Perot sensors. So we have with respect to variation in temperature, pressure, right? So mainly what happens across the reflection concept. So that also I just went on with it. And later I told you about the position sensor as well as the strain and the force type of sensor. So based on the requirement, you can select which type of Fabry-Perot sensor you need basically. So all the types of sensors we dealt, and how exactly the incident and the reflected ray gets reflected, and what do you mean by the reflection polarization, and what do you mean by Brewster's angle. So those also we dealt about. So this is the main principle, how the incident rays come. The incident rays, what usually comes in, will be an unpolarized, right? Unpolarized light, and what we get reflected as a reflected ray will be of an polarized type. So we studied. So this reflected ray will be usually an polarized ray. So all the principle related to this we just spoke about. So you need to know the difference between the p polarized and the s polarized. So s polarized will be always perpendicular to the plane of incidence. If this is our incidence plane, so this polarized, s polarized will be always perpendicular. Okay, so if you can see here, this is the principal plane. So you will be having another plane in which you get the refracted ray. So this will be always perpendicular. Okay, so this is nothing but the S polarized, what we call it as slightly polarized, and fully polarized will be just mentioned as polarized, or you can also say the plane of incidence, because this is the plane in which the incident rays is been passing through. And in the same plane, if it gets reflected, then it is fully polarized reflected ray, what you get. And if the reflected ray comes in another plane, not in the same plane of incident, so then this refracted ray will be always perpendicular to the regular polarized ray, and hence we call this as slightly polarized, or in short it is called as S polarized. So this you should be aware enough. So this I had explained already in the previous class, but still I brushed up since we have a long back of class what we held. So now after that, what we need to start up is, after knowing the concept of Fabry-Perot cavity sensor, you should be knowing mainly what are its applications. Okay. in your syllabus just they have told like sensors associated with the optical fibers. So mainly we have two types of sensors that we have dealt in depth. Another type, the main sensor which is essential for you to understand, is related to Fabry Petrot sensor. So I thought let me explain this also. So all the type of Fabry Petrot sensors and main classification also you are aware about. So where I have told you the slide here, right? So this gives you the entire classification of sensors associated with optical fiber. So it could be either due to point sensors, yeah, integrated, quasi-distributed, yeah, distributed sensor. In that, the mainly thing is related to our Fabry Petrot sensor and the Bragg rating sensor and light interferometry part, what we have dealt. After this, then before going for the next topic, you should be knowing what are its applications. So I didn't dealt about the applications in the last class related to Fabry Petrot sensors. So the applications mainly deals about in making the optimization of the shrinkage behavior of cementitious materials at very early ages. So there are different classifications of the materials, right? We are speaking mainly about the smart materials. In that, here they are telling that this type of Fabry Petrot sensors could be used to analyze the shrinkage behavior of cementitious materials. So there is another class of materials called as cementitious materials, right? Cementitious materials, what do you mean by it? Have you heard about this material before? Hello? Have you heard about this material before? I need a reply. Are you people there? Any guesses?
No.
No. Have you heard about the word cement at least?
Yes, ma'am.
Yeah, so what happens is for cementitious material, you will be adding a binder, which will be like a glue like of material, so that it provides you the some binding across the material. You know the other things what you add on to like with the cement, you add on like the concrete powder and what is the mixing ratio, everything will be known. But along with that, in order to get an actual bonding, now they even use like a glue like material, which is nothing but the binder. So if you're adding a binder or a glue like material to the cement, then it is called to be as an cementitious material. So this type of sensors are basically used to analyze or to optimize the shrinkage behavior of this cementitious materials. If you have this binding type of material, it shrinks the composition of the cement and helps in proper binding. So in order to check how well it has shrinked into the composition of the cement, so if you use this type of sensors, they'll be able to analyze the shrinkage behavior of these type of cementitious material at the very early ages. Okay, so it is like you will make the mixture of the cement and that will be used in construction. So after making it and at the after entire pasturing of this cementitious material, to see every day you put water so that you will get a good binding for the cement what you have applied on the construction of any building, right? So it helps, so you will get a good bond when this binding material gets shrinked and becomes an homogeneous mixture with that of the cement with a good binding. So you should know how well this binding material is shrinked into the composition of the cement. So at that case, in the early making of the building, if you use these sensors, you can understand how was the composition of the cement before, and after like around 3-4 months, how the shrinkage has come into picture. You can analyze by using this type of Fabry Petrot sensors. This is the one application. And second is it can also be used in investigation of textile reinforced concrete components. So again, it could be used in order to see that how well the textile reinforced concrete components are clubbed together. So this is one of the other application. And lastly, it could also be used for, just a second, investigation of the stability of newly developed precast concrete track for high speed railway traffic. So again, one thing you have to keep in mind when you speak about the Fabry-Pérot cavity sensor, it is mainly speaking about the cementitious and the concrete part, which has been used in constructions or building. So it is helped to see the shrinkage behavior of the cementitious material. It is helped to see how well the textile has been reinforced with the concrete components, and thirdly, to see what is the stability of the newly built concrete track. Suppose they are telling it could be checked for an example of high speed railway track. So even in railway track, you need the help of the concrete to get a good proper tracking, which holds the tracks very firmly with reduced amount of vibrations. So when a newly developed track is been made of concrete, so to check what is the stability of this concrete track also, you can use this type of Fabry-Pérot cavity sensors. So these are the three main applications of our sensor, which is Fabry-Pérot cavity sensor. Hope this is clear, the main applications of this particular sensor. Hello? Yeah, any doubts, kindly let me know. So we have discussed the applications individually with respect to other sensors as well. So if they ask you to explain the classification of the sensors associated with optical fibers, you should first give the main classification, then the types of sensors could be explained. Usually they ask you to give the classification and explain one or two sensors. So if you explain, you need to draw the sketch, explain the process and the operation principle, and finally show what are its associated applications. Yeah. So one more last type of sensor is Mach Zend Interferometer. Okay, so this is one more type of optical fiber sensors, so which are being used. So to go with Mach Zend Interferometer, you should be knowing what do you mean by interference. Can anyone let me know what do you mean by an interference? You have studied this right from your schooling related to optical measurements, even in your 11th and 12th standard, and even in your physics in first year of engineering. So you should be able to tell me what do you mean by an interference. What is its principle? How well it helps in passing the light from one end to the other? Shall I call the name or anyone else will explain me? It is a simple concept. Who will let me know? What do you mean by interference? Srinidhi? You can just tell in your own words what do you mean by it. Srinidhi, you're there?
Yes, ma'am.
Yeah. What do you mean by an interference?
Yes, ma'am. In words of light, beam of light passing through one plane, it
Hmm?
distracts me.
Why it get distracted?
Due to there is a variation in uh, there is what to say cut down in the break of that light, ma'am. Passing of that light.
Okay. Why there will be an break or an cut down?
Some object will if it be in middle, ma'am, it will get
What?
diffracted. Like
Yeah, what you call that object as is? Does it operate like a barrier or what it is?
it's it's not barrier, ma'am.
Then,
It's not resonance.
okay, you're partially right, but can I get and clear information more on it? Sandesh,
Yes, ma'am.
yeah, can you put some light on it? What do you mean by interference? He told partially right. Some of part need to be justified.
Ma'am,
Yes.
something which is interfering, ma'am.
Okay.
The
What
light
is
well.
it? Like,
Interferes the wave of light.
okay, what do you mean by it?
Mm,
More numbers. Yeah, what do you
Yes,
mean by
ma'am.
interference?
It's like a superimposition of two or more waves which have the same frequency.
Yeah, so interference cannot come into picture with a single wave. You should be having like two or more types of waves. So if any effect comes into the picture wherein you have a combination of two or more waves which is coinciding or intersecting at a particular path, then you get the interference. You have studied this in your basic physics also. Have you heard about the interference fringes? So you have done some experiment on it also in your first year, right? So this interference basically comes when you have more than one wave which is transmitting along the path. Somewhere it gets coincide or it gets intersected. So in that position you will be having the principle of interference. So here we are using the same concept of interference in our sensor, which is called as Mach Zend Interferometer. So it is named as Mach Zend because he was the person who innovated this type of concept related to our optical fiber sensor, and hence it is called as Mach Zend interferometer. So interference always occurs when you have the light waves more than two. When it is passing, if it gets intersected or combined at a particular point, then this interference comes into picture. And all interferences what we get is always associated with one or the other light waves. Every light waves will be having, yeah, propagating it with its own bandwidth and the wavelength, right? So this type of interference usually arises when you have an electromagnetic field associated with it. So due to this electromagnetic field, when you have the propagation of this type of light waves, it constitutes to see that you have a wave combination. Without any field, you cannot directly make a light wave to get combined. No, even if you keep anything as a barrier in between, it won't combine and intersect, and interference doesn't come into picture because the light waves move with extremely higher speed. So in order to make these waves which is moving in high speed to combine, you should be having some strong force which has been bounded from outside. So it could be a combination of electro with magnetic fields, what we call it as electromagnetic field. So when you have a channel of waves which is coming through, and if it is associated with the electromagnetic fields in and around, so then it helps in the combination of the waves and result in the form of interference. So this meaning you should be aware enough to know or understand the concept of our sensors related to Mach Zend interferometer. So here you can just see how the principle, the schematic diagram of this works in. So basically you will be having two mirrors. So mirror 1 and mirror 2 over here. Okay, so here you'll be having a laser which will be the source of light. So the light will be made to pass through the autocollimator. So you have studied what you mean by a collimator in your mechanical measurements when you were in like third or fourth semester in BE, right? So and later you'll be having an computer plus frame grabber, right? So you'll be having a well advanced CCD camera, so that will be associated to the computer. So you can visualize how the variation has been going on, and to this camera a screen with a magnified lens will be associated with it. Okay, so you will be having, when you have always a mirror, you should be having a beam splitter also. So here you have mirror 2, so you'll be having a beam splitter over here, and again you have a mirror 1 here, and hence you'll be having a beam splitter here. BS1, if it is mentioned, it is a beam splitter associated with the mirror 1. If it is written BS2, it is a beam splitter what we are using associated with the mirror 2. Okay, and apart from that, you will be having two more components in this interferometer. It is mentioned as GC and CC. So what is these two chambers? These two chambers plays a very vital role. If it is mentioned as CC, it is nothing but compensation chamber. And if it is mentioned as GC, it is nothing but the growth chamber. Okay, so you'll be having one growth chamber and you'll be having one compensation chamber. So the variation in both the chambers is associated with two mirrors, right? Compensation chamber is associated with mirror 1 and the growth chamber is associated with the mirror 2. Okay, so both the ways it flows in a closed loop. Okay, so you cannot be specific, right? So it will work in a closed working channel. So this is like the construction, how does an Mach Zend interferometer looks like. So before going into it, you should be knowing like what are the conditions for the interference. So now I hope you're clear with the word. What do you mean by interference? Any doubt in this? Hello?
Yes, ma'am.
Any doubt related to interference?
No, ma'am.
So I'll go for the conditions of interference, what you have to understand before knowing the working principle of the sensor. So what are the conditions of interference you should know about? So you should be knowing some terminologies like the coherent and the identical wavelengths. So what do you mean by this? So in order to get a sustained interference among the source of light, so because you'll be having like not a single source of light, sometimes you might be having more than one source of light, and each source of light is propagating the light in the form of an wave motion. So if in case if you have a sustained interference between the two sources of light, so then the coherence, the interference occurs mainly due to two conditions. What is the first one? The source what you are using must be coherent. Okay, the second thing is the wave, how it is moving should be of identical wavelength. Suppose if you have two sources of light, right? So both this one could be an laser, another one could be an LED. So you are getting the source of light from laser as well as LED. So the light rays which is moving in particular wavelength will be different for the laser and it will be different for LED. So if you have the wave motion in different bandwidth, then it is difficult for interference to occur, even though if you have a strong electromagnetic field. So you have to see that if you have two main sources, so both light wave motions should be similar to each other, means it should have an identical wavelength, equal bandwidth. Then only the interference comes into picture. And the next is they should always maintain a constant phase with respect to each other. So every wave will be having its own sine wave, right? So constant phase. So there might be change of phase while moving. So even though if you have any change of phase while movement, so that phase changing which is happening due to the speed with which it is moving should remain the same. So once you have to see that the constant phase it is associated with, and secondly the wavelengths which are propagating should be identical. If these two are same, then only the interference comes into picture. So these are the two conditions which one has to see if you need to achieve an interference across the light rays which is passing from different sources. Suppose if it is from a single source, you'll be getting a single wave, right? If you have different source of light, and you should see that these conditions matches, then only the interference comes into picture. So these are the conditions for interference what you have to understand. So to achieve this, you should produce coherent sources, right? You cannot directly see that all the source of light which is passing through are associated with constant phase. You should fine tune the source in such a way that the wavelength of the light which is coming is across the constant phase, is in the constant phase, and you have identical wavelength. So now how to produce this coherent sources? So that you should understand. So what is the principle they follow to produce this coherent source? So you have to see how an coherent source is produced. Coherent source in the sense all the light which is passing will be having the same phase. okay, the same constant phase, okay, then only it will be helpful for the interference. So you have to see how an coherent source of light is produced. So mainly you will use an monochromatic source here. So the light which is passing through the monochromatic source is allowed to pass through a narrow slit. I told you that usually the slit plays an important role. Here also we have used two slits. Well, BS is the beam splitter 1 and beam splitter 2. Similarly, the same thing has been told you now. So the light which is passing from a monochromatic source, it could be either an LED source, your laser, your monochromatic light. So whatever type of source you are using, so the light which is passing through the source have to be allowed through a narrow slit. Okay, so you will get a light of a particular wavelength and particular type of phase, and that phase has to remain same. So for that, what you do is the light which is coming from the single slit, why it is called as single slit? Because it is a narrow slit. In this narrow slit only there will be one slit in which the light rays passes through. So the light which comes from the single slit is then allowed to fall on a screen. So that screen will be having two narrow slits. So when you have two narrow slits, what happens is the first light which was coming through the narrow slit will be again splitted. The first slit will be splitted. Okay, so the first slit is needed to ensure that the light comes from a tiny region of the source which is a coherent type of source. So what is the principle here? First you will take the source, which could be a monochromatic source. So the light passes through the monochromatic source and it is made to pass through the narrow slit. So one type of light with a particular bandwidth, with a particular phase will be passing through that single slit. So that single slit will be again splitted into two narrow slits. Where these two narrow slits will be there, it will be falling on a particular screen. So that screen will be having two narrow slits. So you have to see that the first slit what you are using should ensure that the light is passing through that slit only. Because suppose if you have a light source, right, and you have the light which is coming through, so this beam splitter 1 should be having a single slit. So then only a single source of light comes into picture. But here the beam splitter is not a single slit, it is a double slit, and hence the two rays of light has been coming over here. Okay, so I'll come back to that later. But you have to see that this was the old principle which was being used to develop a coherent type of light source. So first light comes from the narrow slit in which only a single light comes. So then it will be made to pass on a screen, and that screen will be having two narrow slits. So the single slit will be divided again to two narrow slits. So then two sources of light will comes through the two narrow slits. So this was the old method which was being used to develop the coherent sources. But now the technology has been changed. So what they do is, so now we are most commonly using laser. So laser has been used as a coherent source. Okay, so here the laser source what we use usually produces an intense, coherent and monochromatic beam of a particular width, right? So no need to fine tune and check that whether you're getting the coherent source or not. If you use in olden days as a monochromatic source, so then you have to fine tune to get the coherent source. So it had its own drawbacks and some initial settings to see that a single ray of light is coming through narrow slit. You cannot allow, if the narrow slit is not proper, so then it can provide you the two source of light waves. So you should be very clear that a single light comes and that single light is again splitted into two narrow slits so that the filtrated amount of light is passed through as per the required phase. So unnecessary phases will be absorbed. So only a constant phase of light will be made to pass through. But in today's technology, when you use laser as a source, so that will provide you by default the light rays of required intensity, of required beam with a coherent value. Means to say that you have a constant phase, the required intensity and monochromatic beam. So it will be having an required wavelength. So it is not like different waves will be having of different wavelength. So you'll have a constant wavelength beams with constant phase with a good intensity which is coming outside the splitter. So this type of laser light can be used to illuminate multiple slits directly. It is not necessary that it can illuminate only a single split. Suppose if this across the laser, if you have kept n number of splitter, the beam splitter, so then it can illuminate n number of light rays at a common time. So this is the basic advantage of using an laser. So and hence I have showed you the two principles, which was the old method and which is now being used. So this is how it will happen. So now you use a laser. So then due to the beam splitter, you will get the light rays of equal wavelength of constant phase which passes through this GC. So what is GC? It is the growth chamber. So here the growth gets happened. So what is the growth which happens usually? So you will be having a chamber for compensation. So the light rays will pass through it from both the splitter. So obviously you'll be having a good intensity of the light which passes through. So you'll be having a good type of light rays of same wavelength and same phase which is passing. So and as here you'll be having an electromagnetic field associated. So when you have an electromagnetic field associated with the wave moving, so then the interference happens. So once the interference happens, that means to say that the waves now have combined. So the combined wave image will be then made to pass through the mirror 2. So from mirror 2, the lights gets reflected back to the beam splitter 2. So here the beam splitter 2 will take the rays of combined fringes, right? So this combined fringes images could be seen through the camera which is connected to the computer. You are using here the screen so that you can see a magnified image, and same image could be stored in the computer. So once the image of the interference has been taken, so then it is sent back to the growth chamber. So what happens in the growth chamber here? So it helps in growing. So what do you mean by growth chamber? So here the direction was in this way, and again the direction was here in this way. But you don't have a reverse direction from the beam splitter to the chamber. The beam splitter cannot transmit the light rays from here to the mirror. It can just take the light rays which is coming from the mirror. So the direction is in this way. So one thing you have to understand, once the light rays are passing through the beam splitter, you get a constant phase wavelength of light rays with equal wavelength. So those wavelengths will be passed through the GC here, which is the growth chamber. So here the combination of the waves takes place due to electromagnetic field, and hence the interference occurs. So the interference occurred light rays are made to pass through the mirror, and this will be made to pass through the splitter. And here from the splitter, the image will be displayed on the screen and that will be captured. So this is one path. And next, similarly, only the constant wave ray, constant light rays will be made to pass through, which has constant phase and constant wave motion. So other source of light which is there will be reflected back to the mirror 1. Means these are the light rays which have different phases as well as different wave motions. So that are being filtered. So these filtered rays of light is made to pass through the mirror. So you have a compensation chamber over here. So this compensation chamber, it is made through the compensation chamber. So wherein the variation in the phases and the variation in the wave motion will be compensated. So this compensated rays will be again made to pass through the beam splitter. So that will be passed to the screen again and it will be captured. So mean to say that the entire source of light which has been passing through is not wasted. The filtered, the required wavelength and the required phase value of the light rays will be made to pass through this growth chamber, So you'll be having the electromagnetic field which helps in making the required interference. So that will be captured in the camera. So the light rays which had different wavelength and different phases also will be rectified by using a compensation chamber. For that specifically we have mirror 1. So it will be made to pass through mirror 1. From there it will be reflected back, and the required interference fringes what we obtain again will be collected back in the camera, and that could be saved in our computer. So this is how the Mach D interferometer works in. Okay, so this is the principle how it works. So here this is named against Mach Zend Interferometer. So if they ask you to explain related to Mach Zend Interferometer, you should be able to draw the sketch, show the principle. Before that, speak what do you mean by an interferometer, what is the condition in which the interference occurs, like how you can develop a coherent source, which was the old and which was a new method. So you, as per the new method, so now this principle is there, right? Then you should explain the principle with the neat diagram. Hope the concept of Mach Zend interferometer is clear. Any doubts in this?
No, ma'am.
Okay, so if you have any doubts, kindly let me know. So the last part what I have to deal is related to fiber optics in crack detection. So this is the main application. We usually know it has been used in telecommunication to transmit the data as the light rays can move in a very high speed with the help of fiber optics. But apart from that, the fiber optics are also being used in crack detection. You have a specific part in your syllabus which focuses only on fiber optics in crack detection. So you should be knowing exactly what do you mean by it. You know what do you mean by fiber optics? You know what is the concept, how does it operate, what are its functions, which are the type of sensors associated with fiber optics, and what is its mechanism also, the characteristics as well you are aware about related to transmission also. So now after you know about so much related to the fiber optics, so now you should think, you know what you mean by crack detection. You have studied already in your BE related to your material science, how a crack comes into picture, how it propagates, and finally how does it fracture. All those you know. But if you use this fiber optic concepts, so before and fracture occur, you can detect the crack and resolve it. If you use a self-healing material, again it is a smart material. So if you make a device using self-healing structure, so with the help of fiber optics, when the crack is detected, the sensor will help you to identify there is a crack. So once it has been identified, so it will wait until the crack propagates. So in a smart material, if you use a self-healing material, so you'll be having micro capsules. So every micro capsule will be having a self-healing agent. So when you make a device, the device entirely using self-healing material and shape memory polymers, so you will be having this micro capsule uniformly distributed in the body in which you have synthesized. So suppose when you have developed a material using self-healing material and suddenly due to some accident a crack comes into picture. So the sensor what you use made up of fiber optics will be able to sense this crack, but it cannot resolve immediately. What does it does? It waits until the crack propagates. It has to propagate and move until suppose the crack was made here and the crack has been propagating. So it waits until the crack propagates and meet a microcapsule. So that crack has to touch the microcapsule. So when it propagates through microcapsule, the self-healing agent which is present inside will come back and it will move related to the area in which the crack was being formed. So that area will get resolved. So that is the application which comes into picture if you're using a self-healing material. So that is also an application. So in that also, if you use fiber optics, it helps to detect and resolve the crack which has been generated. So that is the huge area in which now the research has been going on. But here the fiber optics are just focused in identifying the detection of the crack. So for that, what you mainly need is the fiber optic sensor. right? So to know the crack, you should be using a strain sensor, because when the load comes into picture, when a strain has been induced, if the material is not able to withstand, then only the crack comes into picture. So you should be able to use an fiber optic sensor, which is a strain sensor basically. So this strain sensor will help you to identify any type of crack which has been coming across in the structure. So when you use this type of sensors and optical fibers, the structure what you speak is about the smart structure, not the regular one. Okay, so if I tell you the structure, the thing what you have to come in your mind is nothing but your smart structure. So wherever you have a smart structure which is embedded with optical type of sensors, the strain sensors, so it helps to detect the crack initially when it has started, and hence the damage which can come across in the future could be substantiated, right? So this is the main application in huge buildings and bridges. If you make use of optical fiber sensors, so immediately every bridge sustains for like around 100 to 150 years if it is made up of good material. Wherein if suddenly you have listened, also the newly built bridges have been collapsed. Why? Because the mixture what they have used related to the cement or any composition is not well calculated, and it is not maintained at equilibrium condition what is the maximum load it can bear in. So in that type of things, if you use this type of fiber optics, initially it can detect the crack, and before collapsation of the bridge, it can overcome the problem to be resolved. So these are the main applications of fiber optics in crack detection. So here, as per your syllabus, one of the example what they say is by embedding it in a composite material. You know, a composite material is also like a clubbing of more than 2-3 materials. So if you embed this type of sensors within the composite material in such a way that it fails along with the surrounding matrix material. When you make a material of composite, it is called as a composite material, right? And it is usually a matrix material. Suppose if a matrix material is surrounded along the composite material, and if you have embedded fiber optics sensors in this composite material, if you claim that as a smart structure, so if anything happens to it, so that could identify how an composite has been failed. Okay, so that they have telling, but I've told you the real-time application. You can tell anything which is associated with and which is convenient for you. Okay, so here you can just see a diagram. So this is the embedded fiber, and this is the crack which has been propagating, and this is the structure. Suppose if the structure is made up of self-healing material, and see that the crack will start at this position. So when the crack has been started at this position, if you are embedding a fiber, what is this fiber? Fiber is nothing but the optical fiber. So if in the given structure, if you embed an optical fiber with the sensor, so once the crack has been formed, it detects there is a crack, but still it allows the crack to propagate. Even though the optical fiber is damaged, it helps the crack to propagate. So it propagates until it finds a microcapsule. So that microcapsule will be having the healing agent. So once this healing agent is opened, so this healing agent travels through this crack which has been propagated, and it fills, and the crack or the damage which has come across could be resolved. So that happens only if the smart structure is made up of self-healing material. If it is made up of any other smart structures, then this optical fiber will help to detect there is a crack and there is a danger, and the given structure could be damaged. So an alert will be communicated to the people who is taking care of those smart structure. So once the alert has been received, so then the people can come and resolve the issues. So these are mainly the way in how a fiber optic could be used in detection of an crack. I have told you specifically and few good example related to self-healing material, and in general if any other smart structure is also, it can detect and able to solve the crack damage or the issues in person by the technicians. So these are the main applications wherein the fiber optics are used in detecting the crack or any type of damages in case of smart structures, not in regular structure. A smart structure in the sense the structure is controlled by means of an actuator. So, so you should be having a controlling unit, you should be having an actuator to do the work. For the actuator to do the work, something has to be sensed, so you should be having a sensor. So sensor, actuator and a controller, these three together will help you in getting the required smart structure. So to evaluate any crack or any damages which is creeping into the smart structure, that could be sensed by using an optical fiber sensor. So it could be any type of optical fiber sensor based on the application. So this sensor will help in communicating the crack to the required person, and that will be resolved. So if they ask you specifically, these are the things what you have to explain. How fiber optics is used in crack detection. So this ends the first part. So some applications are there. So to end up with optical fiber, so what are the advantages are mainly optical fibers could be used to get immense bandwidth. So you can get light rays of required bandwidth. So all the light rays of required bandwidth what you get could be utilized very effectively. And secondly, it is used to have an total electrical isolation in transmission media. So we have understood the transmission characteristics of optical fibers. So this helps in isolating in electrical way. So it helps in transmitting the required light rays, right? So hence it is called to be as an electrical isolation. And if you use the transmission characteristics properly, obviously the losses will be comparatively low. So this is one of the advantage. And the other thing is the lightweight. So lightweight, obviously it will not be too high and it will be of small size. It won't be usually visible to our naked eyes. What is the wavelength and what is the speed with which the light has been traversing. We can just observe and sense inside the optical fiber as it is transparent enough. And next, it is highly you get a good light rays of high signal security, right? The signal security what you get will be of very high and specific. So that is one of the advantage. And lastly, you require a very low power consumption. It is not like you need a huge amount of light rays. The source you will use an laser or an LED. So power which is required is very much low, because you just need some amount of light which transmits with equal constant phase and equal type of wave motion, right? So these are the advantages of optical fiber. And lastly, the disadvantages is the installation cost of the system is comparatively very high. So initial investment will be high. Once you have invested, so then you can enjoy its facilities. So one is the drawback, the high investment cost. And you can have only one point-to-point communication is possible. You cannot give like communication to different channels. If you are using a single mode, it is one point-to-point communication only. If it is using multi-mode also, usually the incident and the reflected ray gets coincided across the axis of the fiber, and again communication is in the point means only. It is not like you will get different channels of wavelength which has been transmitted across the outside. So the input phase will be always equal to the output phase. So that is possible only if you have point-to-point communication. So you cannot get a different means of communication. So that is one disadvantage. And the instruments what it is needed are also costly. Installation affair is costly, and to make the smart structure you need some instruments, and even those are costly. And hence if you go for a smart home which is made up of smart structures, comparatively the cost of the smart home will be higher than that of the regular home. Okay, and making this arrangement and getting established as a smart structure, it takes time also. So since it is time consuming, it is one more disadvantage associated with it. And lastly, when you propagate the channel with different codes, it usually accepts only unipolar. It could be not an di or multipolar codes what it accepts. So it is only point-to-point communication associated with unipolar codes. So that is again a disadvantage. It is time consuming and hence it takes a large period of time, and hence also the installation cost is high, and as well as the instruments which are needed to make a smart structure using optical fibers also is comparatively higher. So these are the disadvantages. The cost affairs cannot be reduced, but other drawbacks could be treated to be fine tuned, but that is also difficult. So it is like parallelly it has advantages as well as disadvantages. So one has to think about how these disadvantages could be overcome in future. So if you want to proceed further in research associated with this, you can just try your level best. This is also one more area on which you can think about doing your projects. So these are the advantages and disadvantages. So application part I have told you already. So it is used in medical thing also, in endoscopy. So if you use an optical fiber, it can identify which are the nerves which is blocked, and it can blast open the block in the nerves and make the flow of blood or whatever it is to be proper. So it can burst out the barriers which is there for the flow of blood. So one of the application is endoscopy. Apart from that, you have other applications in telecommunication, in transferring of the data from one end to the other, and also the electrical signals, and also it has been used in military applications. If for decoration purposes, at the night, if you use optical fiber to illuminate the night light, it will look very nice. In case of Christmas and New Year's, also many people use optical fibers to decorate their homes outside for party, everything. So it will play a vital role. Other vital role is in the field of telecommunication as well as in the defense and military applications also. So this is about of today's class. So the rest related to the second part in our module will be taken care in the fourth hour. So until then, everyone please take care and have a nice day. Everyone please write down your name and USN in the chat room. If you have any doubts, kindly do ask. Is it clear? Any doubts? Should I explain this again in the fourth hour? Is it clear? Yeah, kindly let me know if anything which is not understandable from your end. So now answer your attendance. Danush,
Yes, ma'am.
Mithun, Mithun, he was there, right? Mohan Ambal,
Yes,
Mohan
ma'am.
Ambal, yeah. Sandesh,
Yes, ma'am.
Srinidhi,
Yes, ma'am.
Sukrut, Sukrut, Harsha.
Yes, ma'am.
Yeah, okay then. Everyone, yeah, Mohan Ambal, you want to tell something? You have raised your hand.
No, ma'am.
Okay, okay. I think Mithun was there, right, in the morning? No,
Yes, ma'am. He was there.
he was there, but I don't know.
Just now he left, ma'am.
Just now he has left. That's what. While calling the attendance, he has left. I've given him the attendance. Kindly inform as he was there in the class. Okay.
Okay, ma'am.
Yeah, I think only Sukrut was not there.
Ma'am, I am there, ma'am.
When I called, why did you not answer then?
No, ma'am. Actually, I log out, ma'am. The network issue, ma'am.
Okay, 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 okay. Fine then. I've given the attendance. So everyone, please take care and come back to the class on 4th hour. Thank you then. Bye-bye.
Thank you.
Yeah.
Okay, ma'am.